Okay, this is wireless networking with Debian Wheezy using KDE 4.8.4. First thing we're going to be doing is verifying the wireless hardware is detected by the kernel. After that, we're going to be going over a few potential problems that you might run into. After that, connecting to wireless networks, and then turning your laptop's wireless into an Ad-Hoc HotSpot, also known as Wi-Fi tethering. So if you have an Ethernet connection to your laptop and you want to connect a Wi-Fi smartphone, you can do that so that you can share that Ethernet connection with other wireless devices, tablets, or cell phones, whatever. And we're going to talk about turning a laptop into a secured AP mode, or also known as master mode hotspot. For some hardware, they have special firmware for doing that, so it's a little bit of monkey work. So the first thing to verify that the wireless hardware is detected by the kernel, you can check. You can open up a terminal and check the message for anything about missing firmware. Any references to your wireless hardware will be in here. You could run dmessage, and then you could grep for, say, wireless, and here it says this is the driver IPW2200 Intel Pro Wireless 2200 network device. If it can't find the driver, you can run lspci, which will give you a listing of your hardware. And then you can look for your wireless hardware inside here. Network controller, Intel Corporation Pro Wireless, right here. Okay, and then you can do an app catch search for, say, Intel Wireless, and that'll tell you which firmware packages you need to have installed for your wireless to work. So that'd be this one right here, and then you could do a sudo apt-get install firmware-ipw2x00. In addition to that, you should be able to open up your network manager. This is the network-manager-KDE package that gives you this little icon down here. And it depends on the network manager package, which I think works with both KDE and GNOME. There's different front ends for that. So this is just one of the many front ends. One of the things that you can get yourself into a little bit of trouble with, right now I have the wireless hardware disabled with a wireless hardware switch button. It's a little light on the laptop. You push the button, the wireless works, and you push it again, it doesn't work. So I press it once, and now suddenly it shows the wireless. There's a little checkbox here for the wireless. One of the problems that you might run into is if you go into here and you uncheck this wire. Well, before I do that, I can run sudo rfkill list all. And so it says not software or hardware blocked. Really, I only have one wireless networking device, Wi-Fi device in this laptop. It just shows two. I think one of them's fake or pseudo wireless. If I boot the laptop with ACPI equals off, one of them disappears. I'm not sure if that's a bug or not, but I'll show you one thing. If I uncheck this here, this enable wireless, the wireless hardware goes into a state where it's not possible to check this again, so I can't turn the wireless hardware back on again. I just changed it in software, so rfkill list all, and see what it did. It soft blocked this wireless device, but it says that it hard blocked this other wireless device. Now I know for a fact that, of course they should both be, I believe they should both be soft blocked. But now that I've unchecked this, because it's now reporting that the wireless hardware is hard blocked, it's no longer giving me this option to enable the wireless, so it's grayed out. So in order to fix that, all you got to do is run sudo rfkill unblock all, and show what that did. We'll run sudo rfkill list all again, and you see that it removed both the soft block and hard block just by running that unblock all. And then you go back over here, and then I can check the enable wireless once again. So that's one of the things that you could run into. When I first installed Debian Wheezy, my laptop was already in this state where it had soft blocked, hard block, yes, and I wasn't able to enable the wireless here through the network manager. I actually had to look it up Google and find people who had this problem, and this is how you fix it. You can do a sudo rfkill and block all. Chances are this will be fixed before the official release of Wheezy. This is just a bug that I ran into. I've already reported it, so just something to look out for. What was the other thing? Let's see what else. The other thing that you can run into is if you install this laptop mode package. A laptop mode is a package that enables power management for a number of devices in your laptop, say your smart card or your Ethernet or your Wi-Fi, or anything you plug into there. It's going to enable power savings. Now in the past with say Debian Wheezy, installing this package alone did not enable power saving by default. You actually had to go in and configure the laptop mode package and turn on the power saving for your hardware. Now in Debian Wheezy, this laptop mode package will automatically enable power management for all your hardware. So if you just by installing this, it's going to turn on the power management. Now the problem with that is that some hardware might behave a little bit differently when it's being set to this power management mode. For an example, the Ethernet port on my laptop, if I install the laptop mode package, it no longer detects whether the Ethernet cable is plugged in or unplugged while the laptop mode package is installed. I can force it to connect, whether it detects a network cable there or not, but you lose that detection capability when you enable the power management on the Ethernet hardware for this laptop. It's arguable over whether that's a bug or not and how much power it might be saving. But if you plug in or unplug an Ethernet cable and it's not registering that the Ethernet cable is changing state like that, then I'd suggest just try removing the laptop mode tools package, because that's probably the cause of your problem. After that, I can just unplug the networking right here, down here. Just watch, I can unplug the networking, and after a second or so it shows that the networking cable is not connected, it's not plugged in. It actually even says cable unplugged, and I can plug it back in here and it'll automatically connect to my network. Okay, moving on, connecting the wireless network. So we have our wireless hardware detected by the kernel. We could run a sudo ifconfig to make sure that our wireless hardware is assigned, say, an Ethernet. This is actually my wireless here, ETH1. We can do a dmessage, grab say IPW2200 and see what the kernel did with this my wireless firmware. It detected the hardware. This is where I turned when I started the PC with the hardware kill switch on, so on and so forth. It's no longer, the kill switch is no longer enabled, so I can enable hardware here, and it's not hard blocked or soft blocked, and on my laptop the wireless light is blinking, signaling that it's ready to connect to wireless networks. So I can just click on the wireless interface here, and then it'll give me a list of networks that I can connect to. I can just say pick this one, and it'll begin setting up configuration for this. Now before you go into this, you want to make sure that you have your K-Wallet set up, and which K-Wallet is your password management for KDE. You need to make sure that you set this up, otherwise it's never going to remember your wireless connections. There's a manager to create wallets and manage them. Let me see. Right here. See, there's my little wallet that I set up. And I can open it up. Network management, so on and so forth. And you want to make sure that you set up this wallet, otherwise, every time you set a wireless password or connect to a wireless, it's not going to remember it. So it really does integrate tightly with this KDE network management. I'm not sure if they're actually depending on each other, because I believe I can actually remove the K-Wallet package without breaking the KDE network management. you should always run sudo apt. You should be using sudo, not root. Apt-get remove kwallet manager. And see, I can remove this package without KDE networking. So you could have this KDE networking without this kwallet, and then be wondering, gee, you know, every time I connect to a wireless access point, I tell it to save the password, and it never does. I mean, every single time you have to go in and put in a password. And if you're wondering why that isn't working right, it's probably because you're missing your password management, the kwallet manager, and you need to make sure you have that set up. Okay, so now that we have kwallet set up, I mean, it's usually pretty simple to set up kwallet. You just go through a little wizard here, you give it a name, little wizard here, you give a password for your wallet, and just generate it, and then it starts storing your passwords into there. And then whenever an application wants to pull a password from there, it just prompts for a password. So when you run the network manager and I connect to, say, this network here, because I've never connected to this network before, it's going to open up this configure a new or add network connections dialog box. It's the name of the connection, this is the mode, infrastructure. That means infrastructure means I'm connecting to, say, a Wi-Fi router, whereas ad hoc would be if I'm connecting to another laptop. So of course it's infrastructure, automatically handles that. WPA2, I put in the password. Of course, automatic DHCP, it's a wireless router, it's going to give me an IP address. I could hit connect automatically, sure, why not? Actually, I don't want that. Okay, you'll see why later. It's going to ask me the password for my wallet because it wants to store the connection passphrase for this wireless network into the wallet. Of course, don't use a simple password like I used for your wallet. Do as I say, not as I do. And then finish, done. What's that? What happened there? Ended up with 2. Okay, and the password's still in there. Okay. So now we can just open up here, go to the wireless interface, connect, setting network address. This access point is actually a little ways away, so it might not connect. It should connect. Okay, yes, connected to UGG now. Okay, and that's all there is to it for connecting to a wireless network. Pretty simple, pretty straightforward. This wireless manager is really nice, much better than going in and editing a WPA supplicant configuration file with a text editor. Much better than it has been in years past. And you know, if you have a VPN connection, you can set up a VPN connection, and then you could just click on the VPN and it'll automatically, just send the VPN through your wireless interface. It's going to take a minute to connect because it's actually a VPN on the other side of the world, but pretty nice, pretty convenient. And then once that's connected, it's going to show a little padlock down here in the bottom to show that I'm secured over VPN. So there's a padlock down there now. I'm going to plug in a networking cable in addition to that, and now I'm also connected through my networking interface. I'm connected through my wireless, and I've got my VPN through my wireless. Very nice, very convenient. Let's close out of the VPN. Before we get into ad hoc networking, visit Wikipedia and take a look at this page here, the comparison of open source wireless drivers. Here you'll find a listing of all the wireless drivers and their capabilities. It'll also tell you whether or not it requires non-free firmware. Ideally, you wouldn't want a wireless driver that requires non-free firmware, because chances are eventually down the road it might get dropped from the kernel, and it might get dropped by the hardware manufacturer, and then you get stuck on an old version of a Linux distribution, and if you upgrade, maybe you can lose your hardware capability. For an example, say this IPW2200-AP driver, that's been pretty much deprecated. I think the last time they updated it was for kernel 2.6. As far as I know, it doesn't work with the newer kernels, 3.1, 3.2, and so on and so forth. That's not to say that somebody couldn't get it to work with the newer kernels. It's just nobody's cared to do it. So it might require a lot of work if you want to get this master mode capability for this hardware, this IPW2200 hardware, which is what I have. Some other hardware can be in similar situations, and some hardware just don't support master mode regardless of what you're doing. Master mode will allow you to use your wireless hardware as an access point so that multiple devices can connect to it easily with encryption. Some small portable devices don't support this ad hoc mode. Ad hoc mode tends to burn through more battery power. I noticed in Android it gives you a little warning that says, you're in ad hoc mode, you're going to be burning through a lot more power than if you connected to a regular wireless access point. At the very least, I hope that your wireless hardware supports ad hoc mode. That's very nice to have. It allows you to, tether other Wi-Fi devices and to share your Ethernet connection out if you need to. The Atheros chipsets especially are famous for not requiring non-free firmware. Pretty much most of the Intel, I think all the Intel hardware actually requires non-free firmware. If it requires non-free firmware, you're going to find that some distributions like Debian will not put it on their CDs by default, and you'll have to add a repository. You'll have to go in and edit your sources to include non-free to be able to find the firmware. And until you do that, you might not even be able to use your wireless internet connection. So you have to make sure that you add non-free to your apt sources configuration file. You can just edit your apt sources list and make sure that you have main contrib non-free in there, because if you don't have main contrib non-free in there, you're not going to be able to find the firmware that you need to initialize your wireless hardware. So it's especially true if you have Intel hardware. You're definitely going to need that, because the firmware ends up getting pushed out of the Debian installer CDs because they don't want non-free firmware as part of their installation CDs. So you're going to have to go back and later add non-free and contrib to your sources to make sure that you can pick up that non-free firmware that you need to get your wireless up and working. So if you're looking to buy a wireless hardware, certainly the Atheros chipsets are pretty much the best. Just make sure you get a newer one that supports 802.11n and things like that, so that you get the nice performance. The Atheros also support, yes, all the way across the board. They support pretty much all the features available. Moving on to turning your laptop's wireless into an ad hoc hotspot. This will allow you to connect, say, your wireless tablet or your wireless phone to your to share your connection. Well, first we've already disconnected, right? No, let's disconnect from UGG. Here we're connected through DHCP, right? Yes. We could verify internet connectivity there, so we're still connected through, now we're connected through the wired connection, and so now we want to share this wired connection with Wi-Fi devices. Instead of having the Wi-Fi connect to that access point, I could have the wireless devices connect to this laptop, and I'm going to show you how to do that. First, we want to go into Manage Connections. We're going to add a shared internet connection. We're going to call this our hotspot, SSID, hotspot, band, automatic. Doesn't matter. Here you have to be careful because some hardware just is not going to work if you set WEP or WPA2. It just doesn't, unless you're going to need to use different firmware. That's all there is to that. You just hit OK. It says OK, add this to my wallet. This is actually going to be an unsecured no encryption on this connection. And I just click there, and then now it says that the hotspot is connected. You want to make sure that in the management here for the IPv4 address, you want to make sure you choose shared, and that will allow you to share your Ethernet connection with your Wi-Fi devices. And then now with a phone or with a tablet, I can very easily connect to this unsecured hotspot with a very strong signal and get internet access that way. I mean, of course it's not ideal because it's not secured, but if, say, you're at a hotel on the other side of the world and you only have, say, a wired internet connection, and you've got a cell phone that you need to load Google Maps onto or download your email onto, and your cell phone does not have data because you don't have a SIM card, or you don't want to pay the ridiculous international roaming fees, you could have your laptop connect, through your Ethernet interface, and then share that internet connection out through your wireless, very easily. Like I said, you just create that ad hoc network named hotspot with a shared IP, and that's all there is to it, really. This is my HP Touchpad Tablet running Android 4.0.4 Cyanogen Mod 9 nightly build from July 6th, 2012. I'm going to go ahead and connect to the wireless ad hoc network that we created. After a moment, it shows that the wireless network is connected. We can check our DNS settings and see that it assigned the touchpad its own IP address. After that, we can open up a web browser just to verify that the internet connection is working. No problems at all. And now on to wireless master mode networking. The first thing you want to run is sudo iwlist, and that'll give you some information about your wireless and what modes it supported. Right here, supported interface modes. What you want to look for is AP or access point mode, also known as master mode. The mode here that I do support with my hardware is IBSS, which is the ad hoc that I've already shown and tested. To set your wireless hardware into master mode, you run sudo iwconfig and then the name of your wireless interface, which is sometimes WLAN0 or it could be ETH1 in my case. You want to set mode, and then you want to set master. And here it's going to fail because my wireless hardware does not support master mode. Instead, I can set mine into ad hoc mode, ad-hoc. Okay, sudo iwconfig ETH1, then right here mode ad hoc, no problems at all. And then to return, we just run the same command, mode managed, and that puts it back to where it was before. Just to note, when you're running your wireless hardware in master mode, you can have multiple other devices connect to your wireless hardware, and you can share your Ethernet connection. When your wireless is in ad hoc mode, currently it appears that only one device can connect to an ad hoc network. Also keep in mind that master mode is not supported by the network manager, which means this network manager -KDE down here is not going to work to configure that. You're going to need to use some other application such as HostAPD to configure your wireless master mode device. I'd like to mention that the Debian project is looking for more manpower. There's lots of things that you can do to help. You can just install Debian and report bugs. You can translate documents. You can make artwork. You can join the Debian marketing team and get some advertising done. You can update the wiki and how-tos if you're more technically inclined. You can upload packages with bug fixes, also known as non-maintainer uploads, to help out some of the package maintainers in Debian, because sometimes they get a little overburdened, overworked. And there's always people asking questions on the IRC channels. If you can help them out, great. Or if you need help yourself, you can go there and ask questions. That's all there is for today. Thanks for watching my video.